Hi everyone, this is Shivam and welcome to my channel. My channel is about Matlab, and today we are going to talk about quarter card model. So before this, I have make a video about different things, starting with the basic model, degree of freedom, and other thing that built up to this. And further this, we are will be going on a half car model and full car model. So this is how a quarter car model looks like. So sit tight and listen carefully because the this is the next step to the basic to how MATLAB is going to be used to simulate this type of car model. So this is a quarter car model. It has a degree of freedom. It has degree of freedom of value of 2. I have talked about degree of freedom in the previous video, and the link of that video is in the description below to check that out. And so here we are dealing with quarter car model with a sprung mass of mass ms, sprung mass of mass m, and the road displacement, that is xr. So displacement is like this. So due to this displacement, there will be up displacement. Due to this road undulation, there will be going to up displacement of value of x r, and that displacement will going to transmit to this tire that has a stiffness of kt. Now the stiffness of KT, we are not considering here the damping because it is hard to do, and majority it increases the complexity how to calculate the damping coefficient of a tire, and so we are not going to deal with it in this video. But we can do simulate it if we have the value of CT. Now then further the transfer mass is going to with the value of KU, and that displacement is going to transfer with the suspension. This combination is known as the suspension with the value of CS, that is the damping coefficient, and KS, that is the stiffness coefficient. Sprung mass goes up with the value of Kx. Now we will going to use the basic principle of Newton's second law of motion, and we are going to calculate this car boundary, this equation. And now I will show you how we can calculate it from the basic. And so do check it. So firstly we will start with uh, making our model. Then so uh, we have a mass of value of ms, and then that is the sprung mass. Then we go to the sprung mass of the upper body, that is mass of mu. Then the road displacement, that is of a value of kr. We have the r stands for the root. Now we will be going to uh, say the displacement of the unsprung mass is xu, and the displacement of the sprung mass is kx, sorry, xs. And now the damping coefficient with the and the stiffness, this combination is our suspension, the value of ks, and p cs is the combination of the suspension and the tire stiffness. Now we'll do the free body diagram of this. So we'll make firstly our ms, that is the mass that is going with the displacement of xs. Now two downward forces, that is the damping force, and the stiffness force that is going to act below. Now we will put our unsprung mass, that is a value of mu, and that has a displacement of xu or u, whatever you want to say, and it has two forces up. Now FD will be our CS into this capital XS XS dot minus XU dot, that is the velocity. So damping coefficient is the coefficient of the damping force is the coefficient of damping into the velocity, uh, and stiffness here KS XU minus XS. Now this is the FS1, that is the tire, the force due to the tire stiffness, that is KT into XU minus XR. Now after making the FPD of this, we will going to use the Newton's second law of motion. We'll use the Newton's second law of motion and derive the equation that I showed you earlier. So if sigma equals to ma, we will firstly use it for ms. That is our answer. So sprung mass. Now we will sigma x is equals to minus of ft minus of fs2 equals to mxs double dot. As this value is of opposite, that's why we are putting it like this, and we will just write whatever it is, minus cs into xs dot minus xu dot minus ks into xs minus xu equals to ms x double dot. After this we will rearrange it. After rearrange it is will be ms double dot mxx double dot plus cs into xx dot minus xu dot minus ks ks sorry plus kx minus xu dot I have repeated it again. Wait just a second. So the original value should be, here it is, so it is k s, and these are not here, so nothing here. This is just xs minus xu. So now for mass mu we will do the same thing. Sigma f equals to minus plus ft plus fs2 minus fs1, because it is downward, equals to mu xu double dot. Sorry for this clumsiness. Now we will put the value that it has having cs into kx dot xu plus ks into xs minus xu minus of kt into xu minus xr equals to mu xu double dot. Now we'll be going to now we will rearrange it accordingly, and we are trying to make finalize our equation xu minus xr, that is. Now after this it will be mu xu double dot plus cs into xu, sorry k plus kt into xu minus xr, because it's minus, when you go to opposite it will be plus, and the ks will be minus minus ks xu minus xs minus cs xs dot minus xu dot equals to 0. Now we are going to just rearrange it and make it like a form. This is our first equation, this is second equation. So mu xu double dot minus kt xr minus xu minus ks xs minus xu minus cs xx dot minus xu dot. So this is our equation. Now we will just compare it with the equation that was earlier provided. So that equation is, so this is our equation. The first equation is, so this is our equation, mx double dot into cs into ss minus xu plus ks into xs minus xu, and the second equation mu xu double dot xu double dot. Now here it is cs xu minus xs dot. So it is cs xu minus xs dot. As it is negative, these places are switched. Similarly, that goes we doesn't have cs in here, so we will neglect that. And kt pc and kt we have xu minus xr, that is xr minus xu, same thing, and kss. So ks is x u minus xs, same thing. So we verified that this is our equation. Now we will go further and try to develop it further. This is our equation. Now we will going to uh, use this equation to move to our MATLAB model. So this was our equation earlier, ms double dot plus cs into ks dot minus xu dot plus ks into xs minus xu dot. Now ms. Now we will going. What we will do is we will shift it the equation into. Now this is the second equation. Mu xu double dot kxr minus xu minus ks x minus xu. We have to do it carefully, because even if a small mistake will going to reflect in the model, and the result will not show whatever what the right result is. So as we are saying, I've done a mistake earlier. So now we will develop the equation in form of xs. What we will do is we will shift this to the right hand side, and it is cx xu minus xs dot plus kx xu minus xs. So this is the equation. So xs dot will be 1 upon ms cs xu dot minus xs dot plus ks xu minus xs. Lot of xs and s, by god. So so we got this equation. Now this is a very important equation. Now we will do the same thing for the second thing, mu. What we will do, we will shift the half of a equation on the other side. So mu xu double dot equals to kt into xr minus xu plus ks into xs minus xu plus cs into x dot minus xu. So we got this two equation. Now we will make quickly that equation of xu uh, in the form in opposite form, like this value is equal to this value. Similarly goes for this. Now I will try to show you a gist of it in the notebook only. Then I will shift it to the MATLAB just for a better understanding of your. So now we got this two equation. So it's very important equation. Now what we will do is uh, we will we will let's suppose this is the plane of the MATLAB. Okay, this is the MATLAB model. So the basic thing is to get a input and switch it in a loop such that we get the output we need. So this is a This is the differential equation, and it's very hard to deal with the differential equation. It's not an algebraic equation. That's why we are making it as a loop. So this is, we are supposing that is xs, that is our one output, and the below is our second output. What we do is we will suppose that it goes through the integration. So it becomes xs double dot become xs dot becomes xs. Xu double dot become xu into xs. So I will do it in a MATLAB. It is very clear just for the understanding sake. Now what we are doing is we are multiplying whatever this 1 upon this value to xs. So here it will be m into x s double dot. Okay, multiplet column C. It is 1 upon ms. Here it is 1 upon mu. So this value will be mu xs, sorry, ms xs double dot. I'm trying to show you in a backward manner. Originally it's done on the opposite side. So I'm showing what is our output and what we need to do to get our input. So these are the some variable. So whatever goes output in it comes like as the addition of it. It's a rectangular something. Now, so as you've seen, xs double dot we had. So we are now having ms xs double dot and mu xu double dot. So what we can say that this is equals to this box plus this box. So we will add these two, and similar in this case we will add these three. These three uh, as equals to mu xu double dot and in place ms xs double. So as we will have three pluses here and two pluses there. So we will just make a link that the addition of these lines is this. So what we'll do, we will branch it xu, xs and xu dot xs dot. So to get what we need, we are just rearranging, playing it in a loop. So yeah, we will branch it and we will add, subtract it. So this is subtracted plus when these two links goes, the output will be xu minus xs. Xu minus xs. Now we will add a multiplier also in it. So this is a multiplier and the value of that multiplier will be k, the stiffness of spring. So this, after the multiplier, this branch will be k as xu minus xs. We got our one side of our equation. So we had the equation ms double dot equals to 1 plus to second plus. So we got here the first part. Now we will do for second part. We will again add a subtractor in it. So the output of the subtractor will be xu dot minus x s dot, and then we will add a multiplier in it. So you are just like, you can see how we are creating a loop and just using whatever uh, like minimum input we can have. I'm showing you this just to make an understanding. So you can see there is a loop complete, and just using these two value we are getting an output. Now similarly we have to do for the second part. So it is very clumsy in here, so I will do it in MATLAB right now. Okay. So we had this equation with us. Let me show you how to do it. PC is in, so I'll just delete this thing we are having. Now our equation is, short it just for the clarity what we are having. Just very carefully click something. So yeah, we have it here. I will just open our equation quickly. And this is our equation. So, okay. So no, it's not that clear. So we have this. This is the thing we are going to work upon. So one side will be this, another side will be this. Similarly, goes with one side is this, another side is this. Okay. It's it's starting modular advisor. Just wait a sec. So let me close this. Okay. So we have this as our source. We will open the upper Simulink library. We will firstly start with our basic thing. As input, we had the step input. We will just do it with step just to get things clearly and fast. And I do will show you how different kind of input and how bump will work. We do need a various integrator. I'm just putting things randomly right now. We do need a some scope for output, and you can just put it right and you can create copies. Once again, we do need a gain, that is the multiplier I told you. And go. Okay. Yeah, we do have a scope with us. We have source. mm, okay, let's do it again. This is the gain. Now we will need a rectangular. We will have a rectangular sum somewhere in here. This is the subtractor. Where is the sum? Yeah, yeah, we got it. So let's close it quickly. So let's suppose this is our out. Let's start with this excess. Mm, okay, we got this. So let's suppose this is our output. This is the first integrator. The first integrator. So its output will be XS. Okay, so this is our XS. So first output. This is our gain. I will make a copy just by control and clicking it. Once left click it. This will be our XS double dot. This will be our XS double dot. X dot. This will be This is our addition. This will be our multiplier, that is 1 upon m. So firstly we will build this model and then we will add the multiplier to it. So we are firstly focusing on that is the xs. We got the xs double dot, we will multiply with 1 upon m, that is this. So this value will be equals to this thing. So after multiplying with 1 m, this will be our x double dot, and this will be m into x double dot. So this is our two addition. What we'll do is we do need these things input. So I will first make a quick copy of this. Select whole, just click control, make a copy. Okay, select this. We need 3 in here. 3. Okay, we got 3 things. Now this will be our u dot u. Let's remove x. Yes. Okay, so these are xs double dot, xs double dot. Xs. Okay, these are s. And this are u. Okay, so we got this. Now what we have to do is we have to make, you can rotate is just by clicking control R. Select it. Okay, control R, control R. We got in the reverse, we have to do a subtractance of first select negative, enter. This is our subtract. So firstly what we need to do, we need to build this we need to build ks into xu into xs. What we will do, we will connect it here. Xs is on the negative side, xu on the positive side. Okay, and this is our output. We need a multiplier to do the value job of ks. Click on it, control R, connect here. After the connection, this will be our first input that goes on here. Similarly, just select this, select 1, 2, because we're controlling it. Now do for same x double dot xu, xu dot x double dot. This will be the subtraction of these two. This will act as cs. Okay, so this is our, so we got this first loop quickly. Now using these two as an input. Now what we'll do is we have to make a loop for this. Now when you see these terms ks into xu into xs minus xu and cs into xs minus xu dot, these are just the negative of it. So either you can just subtract in here or add a multiplier with the value of negative sign. What will I do is I will add a multiplier. So okay, the value will be -1, enter, -1, enter, just to make things quick. So this will be, what will be, this will be for, goes up, you can move it in. This output will be at x, control set, here, delete this. Now okay, we can later rearrange it just for the aesthetics purpose. Did I click? Okay, we got this. Select this, move it a bit, use it for this, for our CS. So let me just mark it. So it is our KS. This is CS. Because it has a dot line, we will connect it here. So we got our two terms. So now we will make one for our KT for tab. Now the tricking thing about it is we have here KT into XR minus XU. We are using step function as our road input. We can use sine also, half sine, bump, whatever. And this negative goes here. We'll connect to this. This is our KT. Quickly connect this. So simpler. Yes, we got our model fast. So now just to check what is our input, we will make a scope here. To check our acceleration here, we put a scope here. Sorry, here x system dot no. Once you get a hang of it, you can do it quickly if your obviously system permits you. Okay, xu double dot and xu dot, we got this too. Now we have our KT. Now our job is to firstly assign the values. Okay, we got our sprung mass as, so it is 1 upon m. So what we are going to do is 1 upon 600. Enter. You can see this, you can resize it. We got our sprung mass. Now this is our unsprung mass, 1 upon 90. You understand why I'm putting 1 upon, because this is xu double dot when going to be whatever you can, so this is our right hand side part of it, and it is going to be multiplied by 1 upon m, so it will be x double. It's basically loop, this side is equals to this side is equals to this side. So we are just giving it one input and we want two output, and it's very hard to do it in a differential form. It's easy in algebra, but we'll just firstly provide value of kt is 204,034.4. That's our KT. We'll put our C as the damp function of the spring or suspension. We'll put the dimension. We dump is 1000. We'll put the spring coefficient of the stiffness coefficient of the spring 36. Okay. Okay. This. So all the inputs are made, connection are correct. So if we are not making any mistake, we will firstly. So we are giving input at 1 second. Initial value final value is 1. Okay. Scope is in place. Just quickly run it. Yeah. So it started. It generally doesn't take that much time with my PC. So just close this value. So you understand now how we are. What we did is we take put it in a loop, just equify things, so we can get most result in minimum inputs. So what you can just move it. So it's compiling. It's compiled. Hopefully the result will be okay. I haven't missed anything. So firstly start with our input. Pause for minimization. What happened? Let's just first put it in a perspective. Okay. So something is wrong. So to modify, still paused. I might have to load it again. Creating a copy of it. Yeah, it started. So we'll check the scope. Oh, yeah. So at 1 second we have a bump of 1 for 10 seconds. So we first check access. Yeah. So at 1 second the car hit the ground. It goes up and it damped out. As you can see as how it's damping. You can also extend. There are various functions on it. First check. We should check on this. So that was our sprung. Sorry, that was our sprung mass. So here's the graph for unsprung mass. So as you can see, when car hit it, how it is going. Now for our acceleration, what happens to the acceleration? This is how the sprung mass acceleration is varying. 1 second. So this is how it generally runs. You can change timing and other thing using this model configuration. So it has various functions. Even in the output log, you can check when it is actually damping out. What's the time of it? What's the value, average value, and different things. You can change the stopping time, so you can get the graph if it is going at a later time. Then it is useful. Now we have fixed and variable step. There are various types of OD45. We are concluding OD45 and then other things. So you can change the number of continuous minimum steps. So currently it's 1 minute. You can like change it to small values too. So this is the quarter car model. So when you understand the basic of it, it's easier to understand and make it from the scratch. Now we will going to use the same concept for half car and eventually for full car. The things will be same, just the iteration and the value and the extent of it will change. I will firstly do step model for all of this. Uh, Firstly, I will do a step thing for all these models, and then I will discuss about different type of input like sine input or bump input. And further, firstly, you need to understand how these things work. And I'm thinking about making this videos in Hindi also. Do hit me up if you want that. And to shout out to my friend Arjit Ghosh that he told me basically to say his name. That's all. Thank you. To subscribe to the channel.